Thank you very much for your introducing. Good afternoon, ladies and gentlemen. I am an operator of the Northern Area Control Center of EGAT. Today, I would like to present about my project that completed since last year. This is an overview of my presentation. Introduction. EGAT SCADA structure. Problem. Troubleshooting. Innovation. Comparison. And conclusion. Let's go to the introduction. This picture showed the map of Thailand. The northern region is shown in the green area. Consists of 17 provinces. Max demand of the northern region is about 2700 megawatt. Total power generation is about 4000 megawatt, consist of 1 thermal, 2 hydro and 10 small power plants. There are 43 substations and about 7100 circuit kilometers of transmission line. The Northern Area Control Center or NAC is located in Phitsanulok Province. The missions of the NAC operator are to remotely control and remotely monitoring the power system equipment in the responsible areas. The control and monitor tools is the SCADA system. When the power system equipment is in abnormal state, I will acknowledge the event from the alarm of SCADA system. Then I have to request more information from the substation operator to get the event detail. After that I have to diagnose the event. And then I have to restore the system into the normal state as fast as I can. Let's move on to the next topic. The SCADA system that implement at EGAT Control Center is EGAT SCADA. EGAT SCADA is the SCADA system that developed by EGAT staff. It is the low-cost but high-performance. It was implemented at NAC since 2004, as shown in this picture. There are 2 sets of EGAT SCADA at NAC. The main SCADA and the backup SCADA. From this picture, this side is substation. All signal from substation equipment are linked to remote terminal unit or RTU. Therefore, every substation would have at least 1 RTU. This side is NAC. The main SCADA system scans data directly from all RTU. But it is not scan all data. To increase control speed and reduce data traffic, some data were grouped into 8 groups before sent to the main SCADA. On the other hand, the backup SCADA system scans all data from all RTU. The amount of data is about 40,000 points. It scans data sequentially from RTU to CCS, from CCS to GCC, and from GCC to the backup system. This table shows the list of the groups of data in the main SCADA system, categorized by type of equipment. In summary, the main SCADA system has high speed because it scans data directly, and amount of data was reduces by grouping. The backup SCADA system has complete data, but it has low speed because sequentially scanning and a large amount of data. Let's move on to the third topic. The problem that became the idea of this project is a long time of event diagnosis. From this diagram, when an abnormal event happened, I can acknowledge it immediately in the alarm page of EGAT SCADA. But, to analyze an event, I have to get complete information from substation operator. This process usually takes a long time, especially in the non-business period. This problem would take effect to an amount of power outage and equipment damage. From this table, we can see that we take a lot of time to call substation operator in non-business period, and to gathering alarm detail in both period. To solve this problem, we have to reduce time in these items. To troubleshoot this problem, we look back to the alarm page of EGAT SCADA system. This picture is an alarm page of the main SCADA system, and this picture is the backup. The backup SCADA system has complete data, like the data from substation. But it is contained to many alarm from all substations, including normal event. Therefore, it very difficult to search the abnormal event data. From this diagram, we can see that, if we want to get the event detail from the alarm page of the backup SCADA system, it also take a long time. To solve this problem, NAC operators have an idea. To improve alarm page of the backup SCADA system, from line mode like this, into window mode like this. In the new alarm page, the data were categorized by equipment type. Consist of transformer, bus, transmission line, seed bank, shunt reactor, and power circuit breaker. Online Picture Generator, or OPG, is a module in SCADA software. It is a tool to create and modify the display for users. NAC operator improve alarm display in the backup SCADA system by create a new display for each substation. All points must be linked to offline database, and then all display must be convert to online display. All alarm data in each substation will display on only one page. This picture is a new alarm system of Pluralta substation. It is an innovation for the operators to reduce the diagnosis time. When the power system equipment abnormal, we can gather all detail and diagnosis immediately. The relate alarm points will blink in red box until we click to acknowledge them. The box still show in red color until the maintenance staff clear the troubles. This table show the comparison of diagnosis time of the old alarm system and new alarm system. We can see that the average diagnosis time reduced from about 1900 seconds to only 28 seconds. For further implementation, the new alarm system will be implemented in CCS and GCC of all substation in the northern region. Conclusion: the new alarm system can help the operator to reduce the diagnostic time. The information from substation operator is unnecessary. The operator can be able to analyze the problem faster. The system will be brought back to normal much more rapidly. However, the display file must be updated whenever the power system equipment was changed, in order to retain accuracy of the database. And now it's time for your question. Thank you for your attention.